Welcome to Inner Circle session 2117. Put your business on autopilot with IBM Automation Foundation. Today's session is being recorded and will be available for on-demand replay. We also encourage you to participate. Just click the live discussion button on the bottom right of your screen. A window will appear featuring an area to write divided across 3 tabs labeled Chat, Questions, and Poll. Please use chat for your questions to the speakers as well as any other comments. At this time, I would like to introduce you to Bernard Kufluck and Leslie Chow from Automation Product Management Automation Foundation, Barry Mosikowski, Cloud Pak Architect, and Mohan Venkatamaran, CTO from our business partner, Chainyard. Leslie's going to kick things off. Over to you, Leslie.
All right, Bernard, if you don't mind flipping slides, we'll go to the next slide. We skipped it very quickly, but just the standard the standard advisory that what you'll be hearing here is directional. It's potential future products, but it doesn't imply that it's something that we're committing to. Standard disclaimer. Next slide, please. Today we'll take you through a couple of sections. Bernard and I, we're product managers at IBM Automation. We'll talk a little bit about Automation Foundation. You may have heard about that during Think as the, no pun intended, foundational technology to power the IBM Automation platform. So what is that? What is it today? What's our vision for tomorrow? And then we have a demonstration that Bernard will take us through on that's how we intend to build out the vision. And then we actually have Mohan from Chainyard that we have been working closely with to work together to build these kinds of solutions. Try not to reveal too much too early. So let's get right into it. The next, this slide's perfect. What is Automation Platform Foundation? Hopefully you heard over the course of last week, as well as some of the sessions this morning, that our strategy is about making all information jobs more productive, whether it's a business information-centric job or an IT information-centric job. We have heard from our customers, as well as based on a study that we did at the IBM Business Value Institute, that over 80% of organizations believe that scaling AI-powered automation will allow them to outperform the competition in revenue growth. So we've been building the automation platform foundation as the underlying technology to power these cloud packs. Hopefully you heard over the course of last week of how we've evolved our cloud packs to become automation themed, to bring AI-powered automation to the market. We also believe that we can use the same technology to help our business partners, our build partners, like Mohan, we'll talk to you about in a bit, as well as our service partners, to embed AI-powered automation into their solutions. We'll focus on how we enable that in today's session. Next slide, please. I want to talk a little bit about kind of the theme of Automation Foundation. What kinds of problems do we want to solve? And this is a quote from Forrester in one of their recent studies around running your company on autopilot. The notion of a self-driving autonomous enterprise. Lots of words in the article. The key statement that I want to pull out is Forrester argued for the combination of emerging technologies such as AI, machine learning, RPA, edge computing, to enable to deliver self-driving, self-aware, self-correcting, self-directing, in other words, autonomous customer experiences, including kind of timely availability of information. So I want to kind of put a pin on this notion of self-driving autonomous enterprise and go to the next slide and talk a little bit about what we think are characteristics of a self-driving enterprise are, and how that marries to our vision for where we want to go with the Automation Foundation. There are four characteristics that we believe. A self-driving enterprise needs to be insight-driven. In other words, it needs to be aware. It needs to use AI to continuously listen to events, much like those of you that are driving Tesla, or maybe you're a pilot on your off time. You know the notion of self-driving, that using AI to listen to events, to correlate them, and then derive a context, in this case, a business context, to generate some actionable insight that is meaningful to the business. And doing all this in real time, using kind of modern technology to be able to do that all in real time. Going counterclockwise, a self-driving enterprise is, by definition, autonomous. It can self-drive in terms of automation, much like your Tesla. That self-driving automation leapfrogs traditional automation of tasks or workflows by triggering actions based on those insights that you've derived. And those insights need to be relevant to things like your objectives and your KPIs. In other words, it needs to be meaningful to your business. Again, going counterclockwise, one very important aspect of self-driving enterprise, it needs to be observable. If you're running self-driving automations for me, I need to be able to fully explain and account for why I observed something, how I've correlated the events together into something meaningful, and then the actions that I've taken, and put that in the context of metrics to show that the business objectives are met. And then finally, one really important aspect of self-driving automation, sounds ironic, but humans need to be in control. Just like when you're in your Tesla letting your car drive itself, or on a plane as a pilot, you need to be in control. You need to ensure that the business owners are involved whenever the automation falls short, or an exception has occurred and the human needs to interact with it. Next slide, please. So putting that in the context of foundation, we believe that we can enable these kinds of self-driving automations, that we have built an automation foundation, platform foundation to enable that. What is in Automation Foundation? In short, we have a number of services that we believe enable that. We have AI services based on our investments in Watson over the years. We have automation services based on our investments in automation over the past 20 years. And we have a number of observability services as well, to give you that, that human in control and that observability aspect. what's really important is that we build these developer experience, these built for embed SDKs over the use cases that I'll talk about in a second on top. So these new and innovative AI-powered automation use cases are what we enable in Foundation. Today, we'll focus on self-driving automations. You may have heard about Watson Orchestrate as another class of use cases to enable these kind of interactive AIs. And you may have heard a lot already last week about, and this week continuing, about process optimization, what we've done around the realm of process mining to enable the optimization of your processes. So again, focusing on self-driving automations today. Next slide, please. Okay, so how does this self-driving automation work? Let me just touch on this really quickly, and then I'll hand it off to Bernard to show you a demo of it in action. So let's start with kind of on top, the self-driving automations. Our vision is to embed these self-driving automation capabilities in our Cloud Paks. So you would have seen some of that teased out over the course of last week and this week at Inner Circle, and how each of the Cloud Paks are now being more autonomous, right? In the case of WebSphere automation, for example, to help you manage your CVEs autonomously. In the case of AIOps, you might have heard a lot about the incident management and auto correction. So we want to enable these kind of self-driving automation in each of our Cloud Paks. And we also want to enable self-driving automations in our partners' IP. You'll hear a little bit about Mohan, a use case of how he's enabled that kind of self-driving capability within his company's application. So how does it work? I talked a little bit about the services. I talked a little bit about AI services, things like connectors to enterprise systems, things like Watson ML, which is our investments over the years in a machine learning runtime. Things like event streaming, be able to process large amounts of data, connecting to systems, using AI to contextualize incoming data to trigger an action. And that's the first step of a self-driving automation, being able to detect and then decide what to do with it. Second thing, obviously, is to act autonomously. Talked a little bit about the automation services that we have not only invested in over the past 20 years, but some of the acquisitions that you may have heard we undertook over the past couple of months. For example, in RPA, be able to trigger automations from a common automation catalog, being able to surface these automations up. Now will all be packaged in an SDK that, as a project name, we're calling Autopilot. Figures, right? So providing these capabilities through a developer experience to allow you to build these self-driving automations. And then on the side, you'll see how does it work. The IPs will be embedded. Our vision is that the IPs will embed these observability services. So within a Cloud Pak or within a business partner application, you'll be able to observe the metrics. How did that automation, that self-driving automation, derive the context or the metrics that in order to do that, to act. So that's in a nutshell how we envision this works. Bernard, I'll hand it over to you to talk a little bit, show a little bit about what I'm talking about.
Thanks, Leslie. Okay, so demo time. We're going to show you a demonstration, which is going to be a prototype. And it's a prototype of an event-based automation builder. So showing you how we can apply some simple automations to a particular scenario. So what's our scenario going to be? Our scenario is a busy airport. We know airports haven't been busy of late with the pandemic, but we assume they will get busy again at some point. The time is nearing for a flight departure, and the clerk at the gate is alerted that it's time to close the gate. So here's our flight clerk. She's called Emma, and some passengers haven't made the flight. She's got a list of passengers that are missing, and she's got some difficult decisions to make. Should she keep the gate open for a few more minutes to allow them to make it to the gate? Do they have checked luggage? How long might it take to unload it? How important are the passengers? Do they have things that we need to know about them? Like, do they have mobility issues? That kind of thing. What's it going to cost the airline to wait? Are we going to miss our flight slot on the runway? We're going to have to pay more money for that. So she's got a lot of difficult decisions to make, and she hasn't got much information to do it with. Let me just kick off the scenario for this one. Okay, that's underway. Right, let's look at her current experience. So this is her current experience. She's got an application that she looks at when she's at the gate. We've got our flight number filled in there, and we can log in and see what's going on. So this is a flight departing London Heathrow, going off to Geneva. You can see what the time is at the top there. Time's advancing rather faster than normal time as we're playing through our scenario. And we can see passengers are starting to check in as these turn from red to green. And then after they've moved through the airport, she can start to board them onto the plane. And we'll see them start to board onto the plane in just a second. So that's her current experience. She can see what the passenger's doing. She knows that whether they've checked in, whether they're boarded, but she hasn't got a lot of information in terms of deciding what to do if someone hasn't made it to the gate. In this case, everyone made it. That's great. So I'll just reset that and we'll see what we can see if we can improve things. So can we do better for her? Let's add a simple automation. So in this particular case, we are going to give the clerk a bit more information. Let's bring in some information about the passengers as they're passing through security. That's going to enable her to make some better decisions. So in order to do that, we're going to make use of an existing feed of data. I've just got an example of it here. So this is an existing feed of data from the security gates. It tells us which passengers have passed through and their flight number. So how do we put this together into an automation flow? Leslie showed earlier that there are 3 phases: detect, decide, and act. So detect that something's happened, decide what to do about it, and take an action. In this simple scenario, we're going to take the feed of data from the gate as the source and publish that into a security event stream within our system. That event stream is then available in a publish-subscribe model to any automation that's interested in the event. We call that left-hand side the event source. Then on the right-hand side, we have an automation, which does some simple if-then-else style processing before calling an HTTP post to send the information to the gate clerk. So let's see how that looks. Okay, so here we've got the common UI that you'll see throughout the IBM Automation Cloud Packs, especially if you've been looking at the latest releases. So this is the same UI with the same sort of bits in it. But what we've done is in this prototype, we've added 2 extra things to the menu. So there's an item for automations and an item for event sources, which is what we're looking at here. So if we drill in deeper and look at that event source, we can see that we're taking the information from that security feed at the gate, IF demo security feed. It's actually a Kafka topic that we're taking the data from. But there's a wide range of connectors here. There's lots of different systems that we could be getting the data from. Okay, we're then going to publish that into our system so it's available for automations to listen to and be triggered by as events. So we're going to publish it into our system as an event stream, IF demo security stream, and that's got made it available into the system. So let's go ahead now and look at the right-hand side of the flow and the automations. So we're looking at all the automations within the system, and if we drill in and look at the security automation, we can see here that we're picking up that event flow that we had from IF demo security stream. We're doing some simple JSON parsing on it. We reach out to the airline system and get the list of passengers for the flight we're interested in. And then we do the simple if-then-else parsing to check if the flight equals our flight code, and then we'll notify the end application so that she can see what's going on. So I'll just kick off the flow. Okay, that's underway. So let's have a look at the airline demo application now. So here's the application as it was. We're posting in new data now about whether they pass through the security gate. So we need to update our end application to version 2 and log back in again so that we can see data from the security gate as well as information about whether passengers have checked in and whether they've boarded. So we can see the passengers are starting to check in now. They'll start to pass through security in the next couple of seconds as time's kicking by at the top there. Yeah, okay, the passengers are starting to enter security now, and some of them are getting as far as boarding the plane. So that's great. She's got a bit more information now. She can, she understands whether people have passed security. She knows that these 2 are more likely to make it to the flight than perhaps Caden Arrow, who hasn't even made it through security yet. So that's great. We've improved things for the clerk at the gate. But can we do better? So we've done things for the gate clerk with a simple automation, but what about the passenger? Let's add another automation to alert the passenger this time if the gate's closing soon and they haven't boarded. So how does that look in our familiar detect, decide, act pattern? Well, the event source is going to be the gate closing soon event. And that's going to publish to gate closing. Again, we'll do some simple if then else processing to decide whether to alert, and then we'll do a Gmail action to send an email to the passenger to alert them. We're also going to send another alert to their mobile so that they can be alerted through the frequent flyer application as well. I'm going to skip the event source side this time, and I'm going to go straight to the automation because the event source side is very similar to last time. So if we look at the automation for alerting late passengers, we again retrieve the data for each passenger, and if they haven't passed through security but their email is valid, then we'll send them a Gmail. If we look down here, we can see that we're going to automatically create this email, populating it with information from the application. Okay, I'm just going to kick off that flow. Okay, so that's going to kick that flow off and make it actually happen. And if we go back to the airline demo application, we can see Kate and Arrow has fitted what we saw there in the flow. She hasn't passed through security. She has got a valid email. Let's go over and check her email and see whether that's coming yet. So if I refresh her email, we should see in the next couple of seconds. Okay. 1 second here. There we go. So we can see that the email's coming in telling her to proceed to security because her flight is departing soon. Okay, so that was great. So we've done something for the gate clerk. We've done something to alert the passengers. But how can we do better? What if there's a very important person on the flight? Should we treat them differently? Well, in this case, rather than a famous person like Serena here, we're going to define an important person to be someone who's travelled with us frequently, specifically someone who's travelled with us twice in the last 60 days. We're going to use Flink event processing to help us work out who the important travellers are. So one of our sources of data here is a feed from the ticketing system. This stream gets updated whenever a passenger takes a flight. There's a long history of data here. We've got the data from all the passengers whenever they've taken flights, going back months, perhaps even years. So how does this look in our detect, decide, act pattern? We've got two event sources in this scenario, the ticketing feed I just showed you, and the information about our current flight as I showed before. We're going to use a Flink job to bring these two sources of information together and then notify the flight clerk if there's someone who's late but should be given extra time as they are an important person for our definition of important anyway. So here's a snippet of the code used to create our Flink job. I've highlighted the section here where we create a 60-day sliding window, processing the event feed from the ticketing system and picking out customers that have flown twice in that 60-day window. We then combine that with the passengers on the flight we're interested in and the data on who's boarded. So here we can see that the data's arrived from the Flink job. So we get this Flink recommendations appear in the application. It tells us to keep the gate open, and we can drill in to understand why we've been given that advice. So we can see that Kia, Marway, and Anya have all flown regularly with us, and it's worth keeping the gate open for a few more minutes because they're important passengers to us, and we can do extra things for them. So that's great, but can we do better? So the gate clerk now knows who's late, the late passengers get notified, and we've been able to identify important passengers so we can treat them differently. But the gate clerk still doesn't know whether the passengers are really likely to make it to the gate. So let's see if we can help with that by bringing in some artificial intelligence to help. We're going to use some historical data about how passengers transit through the airport to predict when they're going to arrive at the desk. So what we're actually going to do here is I've got, this is a Jupyter notebook, and we've used this to create our AI model. So we've trained this AI model using data about check-in time, how long it's taking them to get to security, day of the week, and passenger age. And the AI builds up a view on how future passengers are going to behave based on previous passengers. We've used a TensorFlow regression model here using linear regression. Okay, so if we look at the AI flow, we can see that one here. So this is the flow for AI advice. Again, we're triggered in a similar way to before, and we're going to fetch the list of passengers as we did before. And then if someone's checked in, but they haven't boarded, we ask the AI and we say to it, for this given passenger, given the details that we know about them, how long is it likely for them to be able to transit through the airport? Are they going to make the gate? We send a Slack message to the gate and to let people know what's going on. And then ultimately we send it on to the system as well, so that they can see it at the gate in the gate application. So how does that look? So rather than the Flink recommendations that we saw before, we've now got a set of AI recommendations. And this time it's getting a bit more specific. It says, let's leave the gate open until 10:54 specifically. And if we drill in a little bit deeper, we get the reasons for why that is. So it says, let's delay for these two passengers, Kia and Caden. We expect them to make the gate, and we've got an estimate of when they're going to make it by. But offload the following passengers. We can afford to take their luggage off because our prediction says they're just not going to make it. So we can start taking the steps necessary to unboard them from the aircraft. We know they're not going to make it, and so we can keep the flight on track for everybody else. So summing it up there, what did we do? We were using automation to help the gate clerk make better decisions. First, we gave her information about whether passengers had passed through security. Then we alerted passengers by email that they were running late, and we sent to their phones as well. Then we used Flink to identify important passengers by processing that historical data and picking out passengers that had travelled twice in 60 days and marking them as important. And then finally, we used AI to predict what passengers were going to do based on past history and help Emma at the gate make the best decision on what to do. Okay, so with that, I'm going to hand back to Leslie, who's going to talk about the roadmap.
Yeah, so hopefully that was inspiring to you all who's connected on the session right now. I'll talk a little bit about the roadmap of how we're actually going to build this into a platform for self-driving enterprises. So the number of steps in our roadmap. The first step is the ability to detect, unify on a single event framework for AI and automation. That's actually already done. So you'll hear a little bit about how our partner Mohan is already using the event framework for AI and automation. A lot of our cloud packs have already started adopting that single event framework. And we have a means for partners, other partners that are interested in learning about the technology to do that as well. What's really in the roadmap is 2, 3, and 4. So we want to build that common brain to derive insights and correlate events. And that can be programmed by either developers using code, like Bernard, you showed with the Flink job, as well as using machine learning models, or directed via natural language by business users. We don't want it to be just for the rich. We want to enable, I think if you attended Mike and the leadership team's session this morning, one of our mantra is we want to enable automation for the masses. So we want to enable business users to use natural language in order to direct the brain into how to process events. The third thing we're going to do is building that ACT capability, building a common framework to build and run automations from across IBM Automation. No secret here, we have a lot of automation technologies in our portfolio that we built up over the years, whether it's a workflow engine in our traditional BAW or BPM space, or it's RPA that we recently acquired mid last year, or our integration capabilities, or App Connect integration platform as a service, or even custom automation logic that you may have built on WebSphere over the years. We want to have a common framework to be able to, these actions to be triggerable, if that's a verb. And then the fourth thing is be able to optimize. We didn't show that capability today, but we want to build that cockpit for business owners to be able to monitor their self-driving operations. Much like the gate agent was able to see the metrics and the data in the application, we want to enable a framework so that partners such as Mohan or Cloud Paks be able to build these kinds of user experiences. All right, so with that, we've been hyping it up for the past couple of minutes. I'd like to pass it over to Mohan to talk a little bit about how he's been previewing this technology and using it in their solution. Mohan, hand it over to you.
Thank you very much, and I really appreciate the opportunity to speak today with the Inner Circle session. What we tried to do here was to take a real-life example and see how the IBM Automation Foundation framework can be applied to that problem. So what I'm going to talk today about is a prototype that we have developed, and it'll be demonstrated by Barry, who has also worked with us very closely, along with Aman, one of my colleagues. I'm going to flip it to the next slide, please. Right. So as many of you may or may not be familiar, Trust Your Supplier is a solution that Chainyard has built and operates it under Chainyard Supply Management. It's a business network that enables suppliers, buyers, and third-party service providers to collaborate on a common platform. And this solution is also a joint venture with IBM. Now, since this is a business network that's built on a blockchain platform, the success of this entire platform relies on suppliers joining the network and becoming members of this network. So that's kind of like the pain point that we have, is how do you enable suppliers to join this network and become members? So let's see what we can do. Please go to the next slide, please. In any supply chain process, the very first step is for buyers to identify who are the suppliers with whom they want to do business. So they identify these suppliers, and then they qualify them and onboard them onto their vendor system in order to conduct transactions in business. Now, TYS, or Trust Your Supplier, leverages the IBM blockchain platform in order to transform that process. So traditionally, it was done inside enterprises. Now we bring it to a common platform on a blockchain solution so that we can have better efficiency, superior experience, and deliver more business value. That's our fundamental goal. So in this platform, buyers invite suppliers. So there is an invitation process, which is the head of, which is the first step in TYS. So buyers send out invitations and they invite suppliers to become members of this network. Now, what we have observed is that of the number of invitations sent out, we usually get a success rate of 10 to 30%, depending on the buyer. Like for some buyers, it's pretty high. For some other buyers, the acceptance rate from their suppliers is as low as 10%. So we want to see, going to the next slide, how can we optimize this process? How can we optimize that particular process? That is going to be the foundation of our use case demo today. But I also want to talk about future use cases on Trust Your Supplier platform. For example, whenever we go into a fast food restaurant, we tend to order burgers. But we all know that when someone orders burgers, they also buy fries and get a drink along with it. So there's kind of an association relationship between these three products. When we look at Trust Your Supplier, buyers invite suppliers. So suppose a buyer invites supplier one and the supplier accepts that invitation, then if we could predict that the buyer should also invite S2 and S3, or supplier 2 and supplier 3, because these three suppliers work very well together and they bring more efficiency for the buyer's business process, then we should be able to enable that. So one of the future use cases that we are looking at is supplier affinity. How can we get related suppliers together and recommend those suppliers to the buyer? Now let's get back to our actual use case. Going to the next slide, please. Okay, let's see how the IBM Automation Framework and Foundation can help us in optimizing the supplier invitation process. There are, when we looked at the automation framework, there are three categories of use cases. There is the first one, which is about operations automation. The second one focused on service optimization. And this one is really focused on business process optimization and business process mining. So we said, why not we use the IBM Automation Framework along with ML to see whether we can optimize the invitation process so that we can target just those suppliers who are likely to accept our invitation and enhance the business network. So let's see what we do. Please go to the next slide. Before the invitation process happens, so today we don't do that. Today, the invitation goes from the buyer to their suppliers. There is no science behind it. It's sent to every supplier that is in the list, and whether they accept or not is a random guess. Now, if we could automate that process whereby the buyer does some pre-work, goes back and looks at information that is available about the supplier and then applies that to the, and uses the ML algorithm to see what is the recommendation, what's the prediction, whether this new supplier will accept my invitation or not, then they have a better idea of how to make better invitations, also how to optimize the process. So we have suppliers who accept the invitation, that's fantastic. And then we have a large population which is not accepting. So can we figure out what are the reasons and how can we improve the acceptance process? So typically we gather, the buyer is supposed to gather data such as what is the supplier's credit history? Where is the supplier located? What kind of industry does the supplier belong to? What is the number of products they offer? And whether they have credit history, what is their credit balance? What is their current revenue? And based on that, we could train the model to see whether the supplier accepted the invitation or not. Now, there are a few things missing here in our demo. We do not consider that, but that is part of the future solution, is that suppliers also accept the invitation based on the buyer who invites them, potential future business that is possible, and targeted revenue. So we don't have those kind of independent variables here, but we are going to use these set of 7 independent variables and see how the prediction might work. So let's go to the next slide and see how we actually leverage the IAF automation framework. So we have to build ML models. So when we build ML machine learning models, there are several classification models available, several algorithms available. And our goal is to see what is the best classification that helps us to determine which suppliers to target. Now, this is a very simple chart. That horizontal blue line basically is a random thing. If you sent out 100 invitations, probably 10 suppliers might accept. But if we applied a classification model, that red line represents an optimal classification model, possibly a random forest classification. And it tells us that over a period of time, if you targeted a specific group of suppliers, then the likelihood of them accepting is higher and higher. Now, ideally, we would like to target those 10% exactly, and we would get 100% of acceptance for every invitation sent out. But in the real world, we would probably look at that red line. How do we improve that red line? By using better prediction models and better algorithms. So that's going to be our goal. So we looked at, let's go to the next slide, please. So this is the IAF automation model, conceptual model that we have implemented in the demo. See, on the top, you see there is data streams. These data streams are publicly available information about the supplier, whether through TYS or from other sources. It's fed into the automation framework, which runs a series of services like Kafka, Flink, Elasticsearch, and Kubeflow. Now, the data is then fed into a model. Now, the vision is that in the future, there will be many different models, M1, M2, M3, and there could be an integration glue that determines which model to actually leverage for this particular data stream, and then train that model. So in our example, the data is flowing into the model and it is fed to M3, and we have a machine learning model that has been trained with third-party data. So tomorrow, when a buyer comes into the Trust Your Supplier network, they could come through the user interface and then feed in a supplier profile, and out comes a prediction which says this supplier is likely to accept the invitation or may not accept the invitation. So that's kind of where we are trying to go with this. let's see what's the next slide here. This shows the type of UI that you will see right now, where the buyer comes into a user interface that's been integrated into the IAF framework and dashboard. The buyer can come in and populate the screen with some profile data. And when this profile data is sent into the model, it's going to come back and say, hey, this supplier is likely to accept your invitation. Now, this is going to help the buyer to improve the invitation process. And it's going to help TYS, which is actually run by a separate business entity, Chainyard Supply Management, to improve the network effect and improve the membership of that particular network. So that's going to be our goal. With this, I'm going to hand it off to Barry, who is going to show us the demonstration. Thank you. And Barry, please take over.
Thank you, Mohan. It was definitely been a pleasure working with your team to put this together. Next slide, please. So what I'd like to show is Mohan talked conceptually about a lot of the pieces that we did put together. And what I'd like to do is actually show you how we implemented those pieces into the actual cartridge that the TYS can expose to its buyers. And I think what's key here is to realize that all these pieces, if you're developing your own cartridge, is, from a developer, your perspective is you want that endpoint. So as you can see here, obviously there's the Kafka, the Flink, all these pieces we've talked about, the Elasticsearch, the modeling, as well as the producing the actual model, the hit-to-earn runtime. The IAF team provides documentation, and they're going to give you all this information in your OpenShift, and they document how you can expose that. So I'm actually going to show how we took this conceptual model and we actually make it work. So let me bring this up. So just to start off with everybody, what we did was we built this with Mohan's team, one of his developers, Aman, who was relentless in making sure we did this perfectly. We developed this on the IBM cloud in the ROX cluster, and obviously this. So I'm just bringing up the dashboard on the IBM cloud where we were managing the worker nodes. One of the key pieces is once you're developing your cartridge, you actually have access to this documentation. This documentation, was very valuable for helping you just walk through all the pieces you're going to need to implement in your OpenShift cluster. And one of the key pieces here is the registration. This is where when you're using the IAF, they don't want to give you any components that you might not need in your development. So you actually can specify through YAML files that you deploy which resources you want deployed as part of your development process and the ones you will utilize. So here's an example where you can see, for example, if somebody wanted Elasticsearch. And the documentation is very thorough, where they actually return in the YAML file the key pieces you need, whether you're using Kafka or Elasticsearch. For example, for anyone familiar with Kafka, you know that you need your bootstrap, an internal, an external endpoint. You're going to need a login. You're going to need crypto material. And it's all just made very available to you. So actually developing the cartridge, they give you the tooling. They make it as easy as possible. And here is actually the OpenShift cluster that we developed this on. And here is that YAML file that I'm kind of just describing to you. And you can see, you're getting the URLs, you're getting the information back that you're going to need to put into your application. So again, as a developer, the points you're going to need is you want your Flink, you want your Elasticsearch, you want your Kafka endpoints. Then there's also the ability to do the modeling, which we showed and we had talked about. And through the implementation of the Kubeflow, you then have the ability for your data scientists to develop using Kubeflow, which pumps into a Jupyter notebook, right? Where your data scientists will be analyzing and modeling the data that you are pulling from your Elasticsearch. And as it's coming up, they're refining the model that they're going to build. So this is all running on that cluster. Everything I've shown you is running on that cluster. And another key piece then is once you've done all your development, and I know Bernard showed this as well, but there's a UI that you basically get for free if you're a developer. And this UI, as you can see, the IBM Automation UI, it's a dashboard that you can easily plug into. And that dashboard could include simply your product, which we plug this in. Obviously, here's the chain yard, as well as in this case, there's actually a cloud pack for integration running as well on here, and you can see its particular tooling. So this is very powerful, and this dashboard also has a lot of administrative functions that you can determine who can access the application, what roles they play. So you get a very powerful dashboard without coding anything, just building the YAML files that plug into the dashboard. But now, simply in this case, we can simply go to the chain yard application that Mohan had showed. Okay, this is what he had demoed before, and what his engineers had put together. And this is just where we refined it at this point in time. So, if you picture the whole flow, we went through the Kafka to the search to the modeling. We've developed a model that the buyer will now expose, TYS will now expose to its buyer. And it helps them determine a couple ways. This supplier, do they really want to send this supplier? Is this a supplier that they can count on? As well as, will that supplier most likely accept this invitation? So that was built into a lot of the AI infused work that Mohan's team has done. And here's a simple case where you put in a credit score. The industry code is specific to TYS, a particular industry. It could be retail, it could be banking, it could be IT. The number of products, the revenue of a particular company, the country location, and Mohan and I have talked about this. Certain parts of the world, might be more likely to accept that invitation, and it just gives the buyer, as the buyer is determined supplier, is a very simple mechanism to do a quick search. And in this case, maybe this industry, this customer that's located in this part of the world, maybe they're not the best. There's not as high a probability. On the other hand, this is actually. In Canada, different revenues, they have more products. This industry is specific to TYS, and the buyer submits this as they're determining a supplier. And in this case, the supplier does have a higher chance of accepting. So, I just think to walk through a real-time use case, and I actually just cut and paste this from VS Code extension since I'm on my browser here, but this was just some of it, I'll call it the stitch coding. So if you picture, there's the blockchain, trust your supplier network, that is, aggregating this data. It would get it to some glue code. This glue code, in this case, is what actually pushes that data onto the Kafka queue. Can pull from the Elasticsearch, can use the Flink job. So this was more, and you can see in this case, it's not like there had to be a ton of code. You just simply had to know your endpoints and feed those engines. So I hope, I hope that shows you a real-time kind of run case of how this was put together, and, how it's, it makes it a lot simpler, that the cartridge developer doesn't have to stand up all this infrastructure. It's at their fingertips. Thank you. To you, Bernard.
Okay, Leslie, I think we've had a couple of questions come in through the chat. So first one I've seen come in is, how can I get access to this technology?
Yeah, so let's start by saying, hopefully everybody got a taste of what we're working on around the Automation Foundation and how we want to enable self-driving enterprises, and a little bit of the application on that in what Bernard did in his POC demo, as well as what Mohan and Barry showed. Specifically on the question about how you get access, at this time, we're opening it up to partners. If you're a build partner that has your own IP and you're looking to quickly embed self-driving automation capabilities, kind of some of the advantages that Barry talked a little bit about in terms of everything's integrated. There's a UI. There's all these tooling that's already pre-integrated. We're opening up to partners. We have a what we call an early access program that we set up. There is unfortunately, we don't have it handy, the link to be able to make that available. But what we will do, I think, post session is update the slides so that we have that link. You can sign up to that early access program, and we will reach out as a product management team, Bernard and myself, to get you set up, much like we did with Mohan. We have a really good relationship with Mohan and the Chainyard team. So when we knocked on the door, they were very interested in using technology. If you're a customer, at this time, we haven't opened it up to end customers yet, but stay tuned on that. That's something that we will be working towards in the near future.
Okay, great. There's another one come in here, which is, I've heard a lot about the Mayflower. Does Mayflower use this automation platform for its self-navigating capabilities?
Yeah, it's a good question. So the Mayflower is a very, very serendipitous. Is that the word? Serendipitous coincidence. I think the Mayflower team has been working on this kind of autonomous captain or autonomous ship for a little bit now, right? And the funny and interesting thing is that it's actually using a lot of the same technologies that we are assembling together in Automation Foundation. For example, a brain, like a rules-based brain to help you navigate some of the international waters laws. It uses AI to recognize images, right? The same kind of AI engine that we're embedded in from Watson. And in the Mayflower's case, they have over 30 sensors on board, physical sensors in this case. It's able to process those kinds of events in real time, capture the images, and then be able to use AI to recognize images. And then that brain that we talked about a little bit earlier is rule-based in the Mayflower's case. And it uses the automation platform components to do a lot of the automated workflows. So serendipitous, but we were very happily surprised that I guess came up with the same conclusion.
Okay, that's great. So we've got another question in here. Will this solution be available for both on-premise and cloud deployments as well?
Yeah, that's an excellent question as well. So as hopefully many of you have heard by now, we acquired a little company a little bit over a year ago by the name of Red Hat. And with the acquisition of Red Hat, we also acquired some of the best hybrid cloud technologies in the world, whether it's Linux or the OpenShift platform that allows us to build and run our technology across any cloud. So that's a long-winded way of saying our strategic intent as an IBM organization is to build our software to make it available, whether you want to host it yourself on OpenShift to run it in any cloud. And because we are now the experts of OpenShift and Kubernetes, we also can run the software for you in our cloud, because our cloud is now based on kind of the same technology. So the super short version is yes.
Thanks, Leslie. I think that's all the questions that haven't already been answered in the chat. So with that, I think probably we're going to wrap up. Thanks, everyone.
Yeah, thanks everyone for joining.